Okay, we're looking at topic 9, which is slope and the slope of parallel and perpendicular lines for the reassessment review. Let's have a look at your first question. It's asking simply, what is the slope of the line? When you're given this on a graph, you know you can count it. We're looking for rise over run. So we count how many up we went, which was 1, and over 1, 2, 3, 4, 5, 6. Because we went up 1 and over 6, our slope is 1 over 6. We do usually keep slope as a fraction, so you do not need to turn that into a decimal. The next question also wants the slope, but now we want the one perpendicular to this line. So we have to first find the slope of the one we're given and then turn it into the perpendicular slope. So again, to find the slope of what we're given, we would do rise over run. And we went up 1, 2, 3, 4, 5, 6, and over 2. So we went up 6 and over 2, and that would reduce to 3. That's the slope of the line we're given. To get the perpendicular slope, we have to take the opposite or negative of it and the reciprocal. So we have to flip it over and change the sign. 3 is positive, so our answer is going to be negative to get the opposite. And 3, if we flip it over, 3 over 1 becomes 1 over 3. So the slope of our perpendicular line is negative 1/3. We go down to the next set of questions. We now don't have a graph, we're just given the 2 points. And we used our formula for slope, which is y2 minus y1 over x2 minus x1. If you remember, the 1s and 2s are coming from which point number it is. So this is point 1 and point 2. We have x, y's in our points, and we would call them x1, y1, and x2, y2, just to show us which point they're coming from. Okay, let's plug our numbers into our formula, and we would get y2 is 19 minus, from the formula, y1 is 0, over x2 is negative 3, and x1 is 7, so minus 7. We then simplify that, and we get 19 over negative 10, which we can show as negative 19 over 10. It's just asking us for the slope, not the perpendicular slope, so our answer is negative 19 over 10. The next one, we want to find the perpendicular. Just like we did with it on a graph, we have to find the regular slope and then turn it into a perpendicular slope. So let's plug this into our formula to find the slope of what we're given. Remember, we're working with x's and y's from point 1 and from point 2. So if we plug it into our formula, we would get y2 is negative 20 minus y1 is negative 16, so I have that double negative going on in the numerator. In the denominator, I have negative 8 for x2 minus x1 is 16. When I substitute or simplify all these, I'm going to get negative 20 minus negative 16. And in the top, well, I will have negative 4. In the denominator, I'll have negative 8 minus 16, which would give me negative 24. I can do some simplifying of that. Negative divided by a negative is a positive, and 1 divided by 24, we can simplify as 1 divided by 6. So this would give us positive 1/6 is the slope. To turn it into perpendicular, as you recall, we need to take the negative or opposite reciprocal. So we need to Take 1/6, positive, make it negative, flip it over, 1/6 becomes 6 over 1, which we can show as -6. Just a two-step process to it. Okay. Now we're asked to find the perpendicular line, and we aren't given an ordered pair or a graph. Now we're just given it as an equation. Fortunately, we're given it in slope-intercept form, y equals mx plus b. We know that the m, or the coefficient of x, is our slope. If we look up to what we're given, our slope here is -1. So if we want to find something perpendicular to -1, we would be dealing with a slope. The perpendicular slope would be, change it from a negative to a positive and flip it over. 1 over 1 becomes 1 over 1. So our slope is now 1. If we move over next to it, we are again given something in slope-intercept form. So to make it fairly easy to pick out the slope, the m that we're given is -1/4. Okay. We are asked to find an equation of the line parallel to this line. When we have parallel slopes, it's the same slope. So we know what our m is going to be, -1/4. We're going to put it into our slope-intercept form. We know our slope. And our b, or y-intercept, can be anything except what we were given. So it can't be -3, but it could be anything else. I'm just going to call it +12, -400, anything except what we were given. Because if it was exactly what we were given, we'd have the same line and they would not be parallel. Okay. Next question is asking us to use the slope formula to find a missing value in an ordered pair. A little different than we're used to, but we can certainly figure it out. Let's go ahead and use our missing value as the variable x, and we can set up an equation for what we're missing. So we know we're looking for slope. We would be doing y2, which is 3, minus y1 is 2, be over x2, which is x, minus x1 is 4, and we know this is going to equal 6. So before we can do a little bit more simplifying, let's see if there's any numbers we can put together. So 3 minus 2 is 1 over x minus 4 equals 6. From here we can cross multiply and figure it out. We would have 6 times x minus 4 equals 1, or 6x minus 24 equals 1. Would give us 6x is 25. And then we would divide by 6 and we would get that's our missing value. Okay. Next we're being asked to write the equation of a line perpendicular. So we know we need to find the slope and then find the perpendicular slope. We saw how easy these were to work with when they were in slope-intercept form. So it's probably going to be easiest for us to change this equation into slope-intercept form. So let's go ahead and do that. We would have 2y equals negative 6x plus 5. Then when we divide both sides by 2, we get y equals negative 3x plus 5 halves. Now that it's in slope-intercept form, we can find our original slope easily. Our original slope was negative 3, makes our perpendicular slope be positive 1 over 3. Okay. We do not need to worry about changing the b this time since they're not the same slope, they'll never be the same line. So our equation of something perpendicular to that would simply be y equals 1/3 x plus any number. Just picking a random number 3. If you were to graph those two equations, they would, this one and the original one and the one we just figured out, they would be perpendicular to each other. Okay, let's look at our last two problems. This one is on a grid here with our A, C, and D, and it's asking us to put in point D that would be parallel. So we know we want the same slope. So what I'm going to do is figure out my slope from C to D and apply that same slope to A. So I'm looking at C and I'm saying that I went up 1, 2, 3, 4, 5, 6, 7 times. Then I went backwards 1, 2, 3, 4. So I'm going to do the same thing from A. I'm going to go up 1, 2, 3, 4, 5, 6, 7 and back 1, 2, 3, 4. And there's my point B. And I can read off of, sort of read off of it, that my points would be -2, 5. Not the only point. Any point with that same slope would have worked. You could have gone down 7 and over 4. Might not have fit on this graph. This might be the only one on the graph you can see, but any other point on the line would have worked. Okay. Our last question asks us, what's the slope of the line? Again, we saw how easy it was to find the slope when it is in slope-intercept form. Because then we're simply looking for the coefficient of x. So let's go ahead and turn this into slope-intercept form. Okay? Our goal is to get the y term by itself, so we're going to start by adding 4 to both sides. That gives us 4y equals -3x plus 4. Now we need to divide everything by 4 to get y by itself. This gives me y equals -3/4 x plus 1. Once I have it in slope-intercept form, I can easily read off my slope here, which is -3/4.